Hello students and welcome. It's Mr. Panza again, just going through some basic algebra problems with you. And I want to go over the rules, which are listed right here on this page. And at any time during the course of the video, if you want to try it out yourself, pause it right here so you can follow the rules step by step to apply them to problems that you see in front of you as you're trying to do some repeated practice today. So I'm going to complete 5 problems for you, and I'm also going to show you how to check each one, but you need to complete the rest of the worksheet, which is 15 problems, and you also have to do what I'm going to do, which is check every single one. So let's take a look at these 5 individually, one by one, starting with number 1. Number 1 is an open number sentence that tells us to add. In other words, it's an open number sentence because the variable a is actually on this side of the equation, not on the opposite side of the equal sign. So we are given the equation, the answer to the addition problem, and the open number sentence is because we are looking for the answer to a. Well, the rule tells us that in an open number sentence that tells us to add, we need to take the 2 other numbers that we know and subtract them to solve for a. So in this case, while you're completing the worksheet, you should connect the 2 numerals that you know, 5 and 9, and in this case, because it's an addition problem, I am going to subtract 9 minus 5, which gets me a equals 4. Now, because we're a little bit new at this, I also want you to check every single one. So you're going to rewrite the open number sentence exactly how it's written on the line here. A plus 5 equals 9. And you're going to replace the a with what you believe a is equal to, which we believe it's 4 plus 5. And as long as 4 plus 5, which in this case equals 9, you can show me that not only do you understand the basic algebra rule here to do the opposite of addition to solve for an open number sentence for addition, but then to check it by plugging everything back in for every single one of these, then I'll know you get the concepts of algebra. That's number 1 for open number sentences that tell us we need to add. We can also take a look at 2 subtraction number sentences. The first is number 10. If the variable is in the first position of a subtraction problem, then we do the opposite again. In this case, we're going to add. So let's take a look at number 10 together. If you look down at number 10, I can see an open number sentence because v is in this part of the question. It's not the actual answer. And v is my variable, and it is in the first position of a subtraction problem. So again, I'm going to take what I know and follow the rule. In this case, the rule tells me because that variable is in the first position, I need to add to solve. So I'm going to take what I know, 14 and 26, and add them together. 26 plus 14 equals 40. I believe that v equals 40. Again, that's not enough for me. I want to make sure that you're checking each one. So rewrite v minus 14 equals 26. Not 14 minus v. It has to be exactly how it's written over here. The equation that I'm circling, the open number sentence that I just circled in black, the same exact way, and then plug in 40 for v. Check with your calculator. If 14 taken away from 40, or in this case 40 minus 14, is the answer you expected, 26, matches 26, then you know that you are solving these correctly and you're starting to get the concept of basic algebra and the rules to follow. Now, the other type of subtraction, like in question number 8, you'll notice that the variable g is in the second position of the equation. It's not the answer, but it's also not in the first position. The first position just simply means that it would be written first. The second position, like in this example here for g, means it's the second one that you see, which actually has a totally different rule. So you'll notice if the variable is in the second position, like written in this rule here, in a subtraction problem, we actually take the 2 numbers that we know, like we do in number 8, and we subtract them to solve for the variable. So in number 8, I'm going to take 20 and 6, and instead of doing what I did in 10, which was adding, I'm going to subtract 20 minus 6. 20 minus 6 is 14. Then I plug it in. Is 20 minus 14, which I'm replacing g with 14 because that's what I believe g is equal to 6? It is. When I check it on the calculator, it checks out. Here's why checking is so important. Let's say you just got into the habit of doing the opposite. In other words, you forgot the rule that because the variable is in the second position, I'm subtracting, and instead you took 20 and you added 6, and then you said that g was equal to 26. Well, if you check, you'll see that you're incorrect, because if you put 20 minus 26, which is the same exact way it's written over here, you wouldn't get 6. In fact, you would get negative 6. And if you get a negative number like this, it means that you did it incorrect. If you ever get something incorrect in algebra, don't panic. It normally means you just did the opposite of what you were supposed to do. So in this case, you go back, you see that you added 20 plus 6, and you quickly switch it. Oh, I shouldn't have added. Let me subtract instead, which then gets you 14. Then once again, go back and check, change this g to 14, and you will see, yes, instead of getting a negative 6, you'll get 20 minus 14 is 6, and it checks off. That's why I make you check every single time to make sure that you're showing me you understand the concepts of algebra and you know how to apply these rules. 2 more rules to get through. Let's take a look at the multiplication open number sentence first, which is question number 5. If an open number sentence, like in question number 5, tells us to multiply, we do the opposite and divide. Let's check it out. Number 5 is one that you may actually know right off the top of your head. Just based on place value, we know that 10 times itself, or 10, is going to get us 100. But in basic algebra, we follow the rule. The rule again tells us that if we're asked to multiply, we divide the two numbers that we have to solve for the variable. In other words, I take 100, I divide it by 10 to solve for the variable z. 100 divided by 10 is 10. Anytime you see a number written directly next to a variable like this, it looks like 10z, that means to multiply. I've written it the same or similar over here in 10 with a star times z, and when I do 10 times 10 to check, place value tells me that when I multiply 10 times 10, I'll certainly get the next place value over, which is the hundreds, or in this case, 100. So yes, in this case, when I'm asked to multiply an open number sentence, I actually divide to solve for the answer. That leads us to open number division sentences, and you'll see examples of this on question number 6, as well as question number 4. Let's take a look at the 2 open division number sentence rules. First, number 6. You have to understand that division, just like subtraction, has to deal with where that variable is placed. So in this case, if an open number sentence says to divide, and the variable is in the first position, like we see here, then we actually don't do this. Cross that out, and this is very important that you make this change, because even though a lot of students will think, hey, I'm going to go ahead and divide because that's the case with what you do when the variable's in the opposite position, instead you actually multiply. So I'm going to go ahead and type that in, make it nice and big so you can actually see it. And I'm taking my time with this one so that you understand this one's different. With division and subtraction, you have to pay attention to where the variable is placed. And in number 6, the variable is in the first position. So in this case, because it's in the first position and it's asking us to divide, we're going to multiply. So I'm not actually dividing. It's asking us to divide, but because the variable is in the first position, we multiply. So question number 6 means I'm going to take 7 and 8, multiply them together, and you get 56. Please understand that a fraction is nothing more than a division question in disguise. Please get used to rewriting this fraction as a division question that you're used to seeing, which in this case would be t divided by 7 equals 8. It's important that you rewrite it, because then when you check it, you can see, oh, my variable is in the first position. Well, no wonder instead of dividing, I actually multiplied, because again, go back to your rules, and the rules tell you if an open sentence tells you to divide, and the variable is in the first position, then you multiply. which is what we did here to get to 56. So my variable was in the first position. We believe it's 56. I'm going to replace t with 56, plug 56 into my calculator, divide it by 7, and sure enough, it will check off, and I will get 8. The opposite can be said for question number 4. Again, I have a fraction, an improper fraction at that. 45 over d equals 5. In other words, you need to recall or notice that this is actually 45 divided by d, which places the variable in the second position. Let's go back to our rules. The opposite can be said for number 4 than what we said for number 6. In this open number sentence, we're asked to divide. We need to divide to find the answer. If the variable is in the second position, then you divide. So in this case, because the variable is in the second position, I take the numbers that I know, which is 45 and 5, and I divide it. So 45 divided by 5 equals 9. So we believe that d equals 9. We've got to check it out. Do 45, replace d with what we believe that variable is worth, which is 9, and see if it's equivalent to 5, which in this case, it will be. 45 divided by 9 equals 5. And there you have it. These are the division rules. And up here we have the addition and subtraction as well as multiplication rules to solving basic algebra problems. I hope this helps. I would finish off the rest of this page and follow the rules that we have printed for you here in class or the ones that are posted to this video.